Okay, so let's talk about another case when a limit doesn't exist. So this is the same as the last board we had, except two new examples, and this is kind of rewritten a little bit. So we have if the left-handed limit and the right-handed limit are not equal, then the limit as x goes to a does not exist. So in this case, we have if we're going to use equations, if the left-handed limit and the right-handed limit are not equal, then the limit of f of x as x approaches a, DNE stands for does not exist. So if we look at these two examples right here, try to solve, it's going to be 4 and 4 little small problems in here. Pause the video and try to solve these on your own. Then when you got them, play them back and see how you did. Okay, so if you've tried to solve these, if we look at this case, we look at the limit of the function as x approaches a from the left. As we come into a from the left, the function is getting closer and closer and closer to positive infinity. As we approach a from the right, the function is going further down, further down, further down. It's actually heading towards negative infinity. So therefore, if we look at the left and right-handed limits, the left-handed limit does not equal the right-handed limit. Therefore, the limit as x goes to a does not exist. Now, even if we put, let's say, a closed dot right here, the limit would still not exist because the left-handed limits and the right-handed limits are not approaching each other, okay? Now, if we want to evaluate what f of a is here, well, this right here is what we call a vertical asymptote. So f of a in this case would be undefined. All right, let's say, for example, we decided to put that, fill in that hole right there. Now, in this case, if we did that, f of a would become 0. So again, that was a case that a function can have a definition at a certain point that's not the same as its limit, or the function and the limit could have the same values at a different point. It's kind of going to vary there. So in this example, if we look at the left-handed limit, as x approaches a from the left, the y value we are approaching is L. Now, if we approach a from the right, the y value we are approaching is P. So if we want the limit as x goes to a, that's going to be does not exist, because the left and the right-handed limits are not equal. They're not the same thing. So here, if we wanted to evaluate f of a, again, we look open circle, closed circle, f of a is equal to P. And again, this once again illustrates that just because a function is equal to something, that doesn't mean its limit is equal to that same thing, because a limit is not what a function is, it is what it is going to.